All right, I'm Travis Eaglin, and I'm the group leader for Group 3, and our experiment is the Cooperian experiment. The objective is to determine the latent heat evaporation using the Cooperian equation over a range of temperatures, and then we will compare that to the steam tables in the thermodynamics textbook. All right, so there's two equations based off of the theory of the Cooperian experiment. We have the Cooperian equation, obviously, which is useful as it relates your pressure, temperature, entropy, specific volume, and enthalpy. And you can manipulate that to get your latent heat evaporation, which we will do in this experiment. Also, too, there's the ideal, if you have ideal gas situation, you can use the equation, which typically relates the same features as the Cooperian equation, but it has the ideal constant, obviously, and it uses temperature. Few safety guidelines in the lab. Obviously, follow the lab safety in the instruction manual. Wear your glasses, long pants, closed toe shoes. We're dealing with a hot plate in this experiment. I don't know if there will be gloves in there, but if you will be touching something hot, make sure you take notice of where you grab. Also, too, anything for electrical fire possibility, please refer to your fire guidelines. So the apparatus, we have one is going to be your 1,000 milliliter beaker. It has the rubber stopper at the top of it. 2 is going to be your hot plate. 3 is going to be your thermocouple, which you have to make sure it doesn't touch your beaker. And also make sure it's submerged. 4 will be your transducer. It has a 9-volt power supply. 5 is going to be your pressure gauge. 6 is going to be your air bleed. 7 is going to be your vacuum control valve. 8 is going to be your pump. 9 is going to be your water reservoir. And 10 is going to be your data acquisition system, which is your computer. Okay, experimental procedure, the data acquisition system. You're going to verify everything's connected. You're going to open the PDAC and open the Cooperian file for the system. You're going to verify all your outputs are configured correctly. Your data will be recorded from 5 to 15 minutes while the beaker heats up to between 50 and 100 degrees C. And also you'll verify your recordings or your data is correct due to the pressure and temperature readings. They should be close to your ambient conditions. Your setup and preparation, you obviously have to wait till the TA comes to start your experiment. You're going to place the 1,000 milliliter glass beaker. It's going to have 2 inches of water in it. You'll set it on a hot plate with the thermocouple set in there, and the tip of the thermocouple being 3/4 of an inch below the surface. You're going to verify that reservoir for the vacuum pump contains a sufficient amount of water. You're also going to close the vacuum control valve and open the air bleed. While doing that, you'll turn on the pump and open the control valve to verify air is being drawn in. And you're going to close that air bleed afterwards, verify the stopper is being drawn in properly. Now, the pressure should drop. And when the pressure is low enough, you'll close that vacuum control valve and turn off the pump. Your pressure should stay low in this situation too. So for the experiment, you'll turn on the pump and bring the flask to its lowest vacuum, leaving the control valve open. You'll set the hot plate to a high setting. You'll bring water to a boil. You'll be at your near zero pressure. Also verify again that the thermocouple is submerged and it is not touching your breaker, just use any kind of data. We'll log the data from the water when it starts to boil, and the pressure will start to rise slowly, closing the vacuum pump. If you do that too fast, it will stop boiling and you'll have to start your experiment all over again. So pay attention to that. You'll verify that with the steam tables that the data makes sense, both your your saturated pressure and your temperature and saturation. Open the air bleed after that valve when the pressure reaches atmospheric pressure to avoid any positive buildup. And then also too, when your water is reaching boiling, you'll stop the data and turn it off. So shutdown procedure is obviously you'll close the control vacuum and the air bleed slowly, and then turn off all your pumps, hot plates, and so forth. Also clean up your area. So mentioned before, we have the Clapeyron equation. It can be manipulated to get your latent heat of vaporization. I took 3 different saturation pressures of 20, 15 kPa and 100 kPa. Here's my results over here on the side. Actually all 3 calculated values were higher than the tabulated value slightly. Also too, in the steam tables, in the thermodynamic book, the steam tables, here's a graph that was created from those values.